Hi, Glenn. Hi, Mr. Kingsland. Okay, so we are here. Hello, everyone. This is another meeting. So today, let's start. Wait. So today we'll cover the problem that we tried to solve in last meeting. Then we want to learn some new stuff about brute force, or maybe we call it complete search. Okay, so we'll start from last problem. Yeah, so jolly jumpers. I don't know if anyone tried to solve this after meeting. I think I mentioned some about the approach. So yeah. Okay. So if I open the tab, let's try to write some idea on this problem. So we want every number from 1 to n-1 to appear as the form of difference, and we want to use an array of Boolean and record them. We set them to false first. If any number appears, we set it to true, and we do a linear scan at the end to check if all numbers are present. Okay, so this is the approach. Now you want to write some codes and implement this stuff. So I'll put it here, I think. Okay. So firstly, let's save it. It's called Jolly Jumper. We don't have this. Okay. So let's see. For the inputs, standard header. This is the standard header we use for every single question, like this. We want to start writing our codes here. This is where my mouse poses. Okay, I will try to make the font bigger so you can read it easily. Let me relaunch it. So this is our code here, and we want to read in an integer called n. And we want an array of Boolean. So for this question, we can see the upper bound is 3000, and now as we know, the differences should take on all values from 1 to n-1. So the maximum value should be 2900. I would just create a Boolean value. Let's call it this, and stands for visited. So report numbers visited. And I want to define a constant n equals 3010. Okay. So after defining this Boolean array, all values are set to false by default. Just pause for a sec. So have you all read the question yet? I think we talked about this in last meeting. You can quickly read the question for a sec. Okay. Okay. No one has any problem with the question statement yet. Okay. So we also want to, one approach is we also use another array to store all the numbers. And for int, we will read in all the n numbers. So we will read all the input with this line using a for loop and reading the input, put them into the num array. Okay. For the second step, we will set our upper bound to n minus 2. So it's smaller than n minus 1 because we want to do some operation here. Let's use diff recording the difference of num I plus 1. Let's use absolute value. So num I plus 1 minus num I. So this is the difference of two adjacent number, or we call it successive number in the array. So it's the i's and the I plus 1's number in the array. We subtract one from the other, take the absolute value, which is the current differences. And we set this diff to true, which means this number, this differences has appeared in our result. So we set it to true. After doing this for n minus 1 times, so you can see there are n numbers. So we take n minus 1 differences. When n equals 4, which we have 4 numbers, we take 3 differences. 1 minus 2, the absolute value of 1 minus 2, absolute value of 4 minus 2, 1 minus 4 at first. So 3, then 2, then 1. So when there are n numbers, we take n minus 1 differences. That's the reason why we use n minus 1 here. Okay. Then we want to do a scan through all the numbers, which is n smaller or equal than 3000. Then we just do a scan for 3000. I equals 1. Because it starts from 1. And let's try not to use 3000. Let's use n. So I smaller or equal to n minus 1. We loop through every single number that we want to appear, which is 1 to n minus 1. Let's see if they all appear in the Boolean array. If any of them is not true, we will realize there's something wrong. Okay. So let's use a Boolean to record. So bool okay equals true. If this I, so here we use not, the logic not here, which means if any of number doesn't appear in the results we get, we will set our okay to false, which means it's not okay, our result is not successful. so it should be not Jolie. So if okay, if the result is okay, we output Jolie. Else we output not Jolie. Let's keep in mind that we want every single character to be the same as the desired output, so the system will recognize them. Otherwise, if we type anything wrong or we type any extra characters, it will cause some problem. Okay, and here. It requires us to, it will input unknown lines. So we don't know how many lines will be in the input. So instead of just writing it for one time, we want to write it for multiple times. So while seeing n, which means while there's an n in the input, so if there is a new line, n will be the first number in the line. So while n, we'll execute these part of lines. Okay. Do something then. Okay. So I think that should be okay, right? This should be fine. So we can start doing them now. Let's see if this works. Oh, do I have to log in? Okay. So we want to send our code and try to run it to see what happens. And make a guess. I think it may not pass the judge, because it's important for us to learn this, that at first, when we define this stuff, what result will we get? I mean, what values will we get? As I said, the values in the this will all set to false, which is in the Boolean bool array, they will all be set to false. And every number in this int array, all integers set to 0. So it seems there's nothing wrong with it, but after every round, we are using the same array and it's not reset or set to anything new. So you can using the Boolean array from the last round or the last line of input, but it gives you the same result for this line, which can cause problem. So this is a new technique that we want to learn. I just want to write it down. So when we are setting reset the array. So when we are dealing with something like when we are multiple lines of inputs, we want to reset the values stored in the array. And by doing it, we can do it in certain ways. The fastest way is to use memset. So memset is a function. It's called memory set, actually. So we want to set the memory of this array to a certain value. Okay. So for every new, I would say every new line of input, we want to use memset, and we put the name of the array, this, we put the value that we want to fill the area with. So I want to fill the area with false. Then I want to determine how many values I want to put in. I will say size of this. Here, let's not use false, let's use 0. So I think this should work fine. And I will explain later why we use 0 here. I think this should pass. So when we are solving problem with multiple inputs, we have to reset the array every time. So the result in last round won't affect our result in this round. So that will prevent getting wrong answer. Let's see. What's the status? Okay, we got accepted. So this code works. And the reason why I use 0 here, it's about, let's see, it's kind of, let's not talk too much about this, but memset actually is from C. It's not something originally from C++. So memset, it's from C because it's about like some operation on memory. And in computer or in like a modern system, we usually store something with multiple bytes or multiple bits. I would say multiple bytes. And about memsets, when we are setting Boolean, in C and also in C++, 1 is, so 0 is false. And anything non-zero should be, so any non-zero should be true. And usually we use 1 for standard. This is only for C or maybe C++. They are not for any other modern programming language, but for C, which we inherited from C. Now in C++, 1 can be used for true. And when we do the memset in C++, when we do memset in C and also in C++, it's okay if you memset, let's see, it's okay if you do some memset array 0 size of array. This is okay, and setting out to false is also okay, but when you want to set it to something else, it's not the same as it. So let's see. Let me give you an example. So, so for Boolean, so let's see. If I want every number to be, so this is not in decimal form, it's in another form that we use to represent number. So if I want the number to be 0x 3f 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 3f, which is a big number, about around, so 10 to the power of 9, I think. Okay, so if we want to set every single number like this, 0x is just a prefix. It doesn't have any real value. So the real value is 4 3f. So there are 4 3f. And using memsets, when we really write code, we want to do ARR. We want to set the array called ARR. Each value should be 0x3f. So we ignore the prefix when thinking about the value. So we just ignore them for now. Then we'll realize 4 of this equals this number. So when setting integer, we are setting actually 4 parts. So you can imagine there's an integer that's stored with multiple bytes, and using memset, each time we are setting only 1/4 of the number. So we have 3f here, 3f here. We set every part to 3f, then the overall number will be 0x 3f, 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 3f. So it's just something else to cover. So this is a special technique in competitive programming, because when you want to initialize something to a really big value, but we don't want it to overflow, we will set it to some number like this. So it will not overflow easily, but it's also very big that we won't get this value in normal calculation. Okay. So just remember this, I think. Just remember mem sets. Usually we set them to either 0 or 1 or -1, or maybe we set them to 0x3f. These are the most common ones. So this is the name of array. This is we just use size of array to take the size of memory of that array. And this is what we want to fill in to the array. I think, any question? This is not an important technique. It's just useful when you're dealing with multiple inputs. Do we not have any question? You can type in the chat if you do want to ask on anything. Or maybe we are okay with them. Okay. If we are okay with all of these, I will just mention a new type of question today. So this is an ebook written by, I don't know who wrote this. It's an open source and free book. I will send it. I'll put it in the classroom sometime today. So we will be talking about some ideas from them, because it's easier than me just writing a lecture. So I'll use this for quite a bit of time. Okay. Is this big enough? Yeah. Okay. So let's talk about brute force today. Brute force, we shouldn't use brute force. It's a negative word. Usually we use a more formal name, complete search. So as the name suggests, complete search is basically searching for every possibility to see which one fits your requirement. So if we want to generate a number that fits certain requirements, and we are using complete search, all we do is generating every single number that we can get from 1 to infinity and check which fits our requirement. So it's the most common method, and usually it's from common sense, it's our first choice, because before you get any formal training on programming, your first choice, or your, let's say, your intuition will just bring you to complete search. And many introductory problems can be solved with complete search, but harder won't be so easy, but it's still useful. Okay, so we want to talk about complete search today. Our first way is generate and test. Yeah, so generate and test. These questions are they're kind of too complex for us, so I don't want to use them as example. Let's just, okay. So let's think of a question. So if there are 3 numbers, okay, 3 numbers, which are A, B, and C. We want to find AB, let's see. ABC. We want to find such a pair that A plus B plus C equals let's say 15. A plus B times C equals 100. We want to find such triple numbers that fit this condition. It can be simple, right? We just want to, we can just generate the result ourselves. We can just calculate it by hand. But if we want to count how many, let's see, possible triple of numbers we can get, 0 smaller or equal to A, B, C smaller or equal to, let's say, 30. Okay. So in this constraint, it's small enough that we can use complete search. As we talk about time complexity in complete before, usually complete search is, usually they have n to the, let's see, on to the power of c, where c is a constant. So for here, it should be on to the power of 3, where n equals 30. Okay, let's use, yeah, n equals 31 actually, yeah. So this is the time complexity. And as we know, if n increases to a larger number, like 1,000, then we can solve this in the given time. So complete search, a good thing is some pros. Complete search is easy to code, easy to think of. Let's say, and some disadvantages. So they are not efficient enough. They are usually not efficient enough. And they require some optimization, I think. Require some optimization. So you can see, as, let's say, as a beginner, as also as for when I was a beginner, so we usually solve many problems involving complete search, and after solving them, you can kind of optimize your method. You can think of more efficient way by making changes in your code, and you can try to learn some more advanced stuff. But complete search is usually the most common method. You will spend the most time on it, I think. You may spend like 2 months just solving one kind of question. They're not of same kind, but you will use similar approach. Okay. Okay, so let me start a screen. Let me start a. Oh no, share.io, I guess. Yeah, I think this is the correct one. So I will start a code share now. You can join in, and we will write some code here. I'll just wait for everyone to join so we can kind of write some code here. Okay. Let's see. Okay. I send it in the chat box. You can copy and enter the website. Okay. So we want to solve this problem here, where a plus b times c equals 100, or 100 here. And the constraint is 0 smaller or equal to a, b, c smaller or equal to 30, which means a can be 0 and a can be 30, same as b and c. So we want to write some codes. Write some codes to count how many possible how many possible solutions? Okay. We can start writing them actually. You can just enter the web page and we can start writing the codes here. I think this is more convenient than me talking. So you can kind of write your code. Any question about entering the web page now? Hello, everyone.
No.
Okay, you can kind of start. Everyone can get some space here. The standard form will be just to write this because this name is a bit too long for you to remember. Yeah. Or you can use this. You can just choose any one of them. Either one should be fine with this question, since you don't need to use any special function. I think just some normal function that we use. It depends. Okay. So we want to write a triple, let's say, I don't know. It should be called a triple for loop. It has one for loop in another for loop in another for loop. So it's like for loop with 3 layers. One is A, one is B, and another is C. Then if A, B, and C both, and if this A, B, and C fits your requirement, you can add your count. And at the end, kind of the count is your result. It should be kind of like that. Just some hint. When writing the for loop, it's important to check the constraint when sometimes there may be a smaller or equal to, or sometimes people may give you simply a smaller. So it's important to take that boundary so you don't fall into some mistake. You can use tab for indent, yeah. We don't need to output every single solution. We just want the final count of how many possible solutions we can get, just to clarify. So usually the question will be clear about what they want. So it's important to note. Are we done with these questions? Oh, you got 78? Okay. I don't really have a result for this question. It's just a question that we want to get some code. I think the result should be fine as long as your code is right. So we just check the code, I think. If A plus B equals 100, I think your code is correct. Yeah, I think your code should work fine. Okay, so after solving this question, we get the sense how complete search works. So usually complete search, I'll just copy your code. So usually complete search, not this part, not this part. So if some condition, for complete search, usually we have different layer of loops, looping through each variable that we want to use. Then if some condition is met using with these variables, we will maybe make a count or maybe output the solution depending how the question wants us to do. So that's the complete search, and we call it, usually we call it generate. So the first way is generate and test. So generate test is called, firstly we generate all the possibility, then we test, or maybe we check if any of them meet our requirement. If one possibility, if one solution meets the requirement, we make the count plus plus, or maybe we output the solution. So we make it count plus plus here. So that's the generate and test approach. There are harder approach involving recursion or involving some searching. So so DFS is also used. DFS is also used for complete search, as we can think of. DFS is about searching all the way down until it doesn't work, until there's no way to go, then come back to another row. So from complete search, we can use DFS because it searches to the end of this, like I would say, branch or the solution. It doesn't work, it goes back. So for some question, we use DFS instead of the simple iterative way. So DFS and recursion is also common. So let me see if we have any. These questions, some are, let's see. Let me check if any questions are good for us to solve. Okay. So I think there isn't many good questions which are easy and fit us. So I think I will try to find some good question about complete search. This so code force randomizer. Let me see. Okay, let's just so from today on, since we have only 2 meetings left, we're gonna start solving some questions on Code Forces, which is an, I think, Russia coding website, a Russian website. Yeah, this question. This is our first question for homework, or maybe for like after meeting exercise. I will post it in the classroom too, post the link there. We will talk about this question at the beginning of next meeting, I think. Or we can kind of write some codes for it now, since we still have, let's see, I don't know. We still have a few minutes left if we are not leaving now. So it's May 26th, about complete search and test. So code forces. So this is the problem that we want to practice on after the meeting. We'll get time, and from now on we are not gonna learn one topic in the meeting because it's hard to understand those and put them in use immediately. Instead, we want to do some practice, and practice is I would say, most reliable way to improve for competitive programming. You have to do tons of questions to improve rather than just listening to lectures. That's for like research or studying in college, while solving problem is more like for competitive programming. So we want to solve more problem, I think. Less lecture and more coding, problem solving, and so on. So for each question on this website, this is called rating, or we call it difficulty tag. So the lower the score, the easier the problem is. The higher the score can be like 3,400. That's I'll say, the hardest question in the world in some way. So we can start from 800, and if we are okay with 800, we can kind of go to 1,000 and so on. And there aren't many meetings left, so I'm not sure if we can really go that far. But today we talk about complete search, and we talk about set. So resetting used to reset the values in an array. Okay. And we also finished the question from the last meeting, so I will post the source code online, I think. Jumpers. If you have any question on the implementation for those parts, I'll put them on the website too. And I think that's it. If you do get time this week, since there are only, I don't know, few meetings left, you can try solving some questions on code courses or just for this question. So for A, watermelon, this is a good question, which I think we can solve it independently. Yeah. So if you do get time, you can try this. And that's it. Now. Yeah. Any question from about the stuff that we covered today, or maybe about the Jolly Jumper question? You can type in the chat or just unmute yourself. Okay, guess we don't have a problem. Okay, since we are not, I didn't see anyone leaving now. We can kind of work with this question by the end of meeting, I think. So watermelon, we can read the question first. It's just about buying a watermelon with some kilograms. We want to divide the melon so each of the two parts weighs even number of kilos. And it's not obligatory that the parts are equal. So we want to see if it's possible or not for the boys to cut the watermelon and into two parts, and both parts have an even weight. So both the weight of both parts have to be an even number, and they don't have to be equal at all. So if you want, you can enter the co-share. Oh yeah, enter the co-share again, and you can kind of just write down some approach. So do you think they can be divided by something, or if the number has to be the product of certain number, or it doesn't have to be any special number? Kind of write down what you think. I don't like this, so let's change to another one. Dual tone, okay, good. So, any thoughts? We want to divide it into two parts. They don't have to be equal, and each has to be an even number. So let's think. So the overall weight, W equals W, let's say W1 plus W2. And we want W1 and W2 to be even. Both be even. So both W1 and W2 have to be even number. And so I will ask some questions. You can kind of type in the chat if you know the answer. So what about W? So W is the sum of two even numbers. Is W odd or even or either, or it's okay. So who wrote even here? You can write your name. Is it Glenn? Yeah. Okay. What about Kara? What do you think? Even? Okay. So we agree that W should be even too. And let's see. So for competitive programming, when solving such questions, we want to get some real reason why. Okay, so W should be even. Then let's take to try. Let's see. Let's take number, I would say 6. So let's say 2 actually. So for 2, it's an even number, right? It's even. But what do we want to divide 2 by? If we want to divide the watermelon into 2 parts, either W1 and W2, they should be greater than 0, right? They can't have a weight of 0, then it's not a watermelon. So they have to do they have to be greater than 0. And we want to divide 2 into 2 parts. We can only divide it to 1 and 1, right? So 2 is the work. So what about, let's try 4. Okay, let's try 4. We can divide 4 into 2 and 2. So 2 is even and 2 is even. Let's try 6. We can divide 6 into, remember the 2 parts don't have to be equal, so they don't have to be half of the, so 6 can become, let's say, 2 and 4. 2 is even and 4 is even. Wait, what happened? There's a pattern. So there's kind of a pattern. So for any, let's say, any even number, whatever number it is, so imagine if it's, let's say, 100, it can be the sum of 2 and, because the difference between every 2 successive, or we call them adjacent even number, they have the difference of 2. So let's say for even number, we start from either 0 or 2. Let's say 2 to 4 to 6 to 8. They have a difference of 2, difference of 2, difference of 2. So for every even number, we can divide it, we can separate it into another even number and a 2. Applies to every single even number. We can use 80, which is 2 and 78. But in this question, so from the math view, 0 is an even number, which satisfies our requirement, but 0 is 0, which doesn't bring any real meaning in real life question. So for 2, it can be divided into 2 and 0. There can be a watermelon with 0 kilo. There can be a 0 kilo watermelon. So 2 doesn't work, but any other even numbers work. So from 4 to 100, I think those all work, right? Yeah. So that's kind of the approach that we want to take. We want to first find some pattern, then we want to get some examples to see how the pattern works, to see what the rule is. We want to use this rule and to solve the question. So the rule is W should be even, and it also has to be greater than 2. So it has to be an even number greater than 2. An even number greater than 2. So that's our overall requirements. And from the thinking process, this question is starting to implement it now. And this is 800, which is the first question in most competitions. You can kind of just solve it now. So it means you are able to solve many first. So you are able to solve the first question in, I would say, half of the competitions. That's some good news. You're able to participate and solve a question now. Okay. So our requirement is W should be an even number, and it should be also greater than 2, because 2 equals 2 plus 0, while 4 equals 2 plus 2, 6 equals 2 plus 4, and so on. Any question on this? You can just type your question if you do have one. You can just talk. Have fun with both. Or you can just type 0 or maybe false if you don't have one. That's because 0 stands for false in C and C++. Okay, I think no one has any question on this. Okay, so by firstly we think about matter. Then we want to get some. Oh, I think they're too small to see. Think about the pattern. Then we go and explore. Can we like find the pattern and code the solution? So even though we call it coding competition or sometimes programming competition, the most important part is about thinking and looking for the pattern instead of really writing your codes. So if you just start writing codes before you understand the question, I would say it's not a good habit. So when we are solving these questions, we will try to force yourself not to write any codes unless you are sure you are confident with your codes. Otherwise, you will have to use, I don't know, pen or pencil to write down some thoughts, simulate the process to understand what the question means. Also, when solving the question, example is also important. So when they give 8 and the output is yes, which means 8 is a valid solution, you can try to understand why it is valid. And maybe some question will give you some other examples that they don't fit the requirements. You can check your understanding of the question against these examples and maybe get some other new thoughts. So I think people are tired now. I'm not sure. It's been an hour for our meeting, so I think that's all for today. I will post another question in the Google Classroom because we just covered this too quick. Or maybe, yeah, I think I will post another question. So, do you want to leave, Glenn or Kara?
Kevin, I've got to go, so we are going to have to pack it up now, unfortunately. But
yeah, I'm just thinking about ending the meeting now.
Okay.
Yeah. Okay. I think we are done. So they both leave and.
Oh, okay.
See you, Mr. Kingsland.
All right, Kevin, thank you so much. Wow, you once again have put an amazing amount of effort into preparing for this. It's really, really impressive. I could see you one day as a university professor. I don't know what you're going to go into, but very, very good job. Very good job explaining as well, too.
Okay, yeah. See you.
All right, take care. Have a good day.
You too.